My car gets towed, no.
They don't do it baseball.
No, just people park, like random people park there, like walking dogs.
Yeah.
To be fair, I just say student parking.
So that means we walk me today.
Yeah.
But that was upset about it. Yeah, why do you sound so upset?
Dude, my energy's confused because we're talking about new projects. We only have a week.
All right, if you guys can turn to page 24.
I was being very much bullied. They tied my shoes super tight, and now it's bothering me. And I don't know if I'm gonna be able to go really fast.
It's a group project.
Look at this a little bit later in case you want.
The receipt. I only have the first two local practice things, and then I'll take the test.
My valid journal is copy pasted.
So we're going to finish up on graphing. You know, we covered everything that all the new stuff on Friday, but I just want to do a little bit more review, make sure that we can find those order pairs, take advantage of the log properties that we learned to find order pairs and then graph. And but I also want to review a little bit with transformations, and then we should be able to start our test review today. We'll finish the rest test review tomorrow. The test review is a lot longer than the actual test. The test review is 4 pages, but the test is only 2 pages. There's just a lot more examples of the types of problems that you're going to see on the test review. There's the option for you guys to take the test on Wednesday. However, the test is still Thursday, but some students may prefer to take it a day early. But I have to take students down. I have to use Wednesday's 7th period to take the class down and return devices. So I think that's going to cut into the time 7th period for students who want to take the test Wednesday. However, you can still take it Wednesday morning, Wednesday 4th period, or Wednesday after school. Okay, I don't think there's enough time in the class period to allow for a full period for you to take the test in class. But we're still going to be able to use Wednesday then to do another review day, or at least a half period. Hopefully it won't take the full period. I'm not asking you to commit to this, but how many students would think about wanting to take the test on Wednesday? Okay, so about half of you guys. So you guys can just have to figure out a time for you to come in either before school, 4th period, or after school. Okay, if you really want to take it on Wednesday. Yeah, but yeah, that is set for us. We have to do it on Wednesday, so I can't work around that day, at least not that I know of. Okay, yeah.
Do we have the properties on the test?
No, the properties you have to know. Okay, you have to know.
Do we have to know like the log 1 equals 0?
Yeah, this is going to be really helpful for your graphing. Yeah.
Do we have to like know that, or would that be like?
I'm not going to ask you a specific problem where you have to tell me those properties, but you have to apply it. Is that what we're asking?
It's the last test of the year, and you don't even get the formula.
Not the formula.
I'm not gonna say that that's lame, because I don't wanna.
Yeah, you should make the last test of the year like easy, so if someone fails, they don't like fail.
Hey, can we do this as part of the test this year?
That is such a good idea.
Well, if you fail, you can always take for recovery.
You must be joking.
I just want to be John.
I literally do not plan on coming to school after Wednesday.
Okay, so we'll talk about that later if you have individual questions. Okay,
One of the other.
so page 24.
Did you say 4? Oh. The crisp dollar bill. I have a nice $5 bill sitting in my car.
Okay, so bottom half of page 24. It says sketch and analyze the graph of the function. Okay, so describe domain, range, intercepts, asymptote, and behavior, and where the function is increasing or decreasing. Okay, so let's rewrite this. Y equals log base 1/4 of x. Okay, so let me review the graphing properties that's going to be help or these helpful log characteristics. First thing is the argument. Okay, so the argument is whatever is inside the parentheses. We set that equal to 0 to find the vertical asymptote. So where's our vertical asymptote going to be here? 0, right? If I set that x equal to 0, there's no need for me to do anything with. There's no algebraic work to be done. That's already showing us the vertical asymptote. So I'm going to go ahead and create a t-chart. And I'll put 0, and that's not actually a point on the graph, but I'll just put VA for vertical asymptote. Horizontal asymptote will be for exponential functions, but we're not going to see exponential functions graphing on the test. Yeah. So logs is only going to be vertical asymptotes. Okay, next up is what can we do to get this property to work? What can I choose for x? 1, right? So if I choose 1 for x, log of 1 is going to be equal to 0. Okay, next up, log base 1/4. Let's see, what can I choose for b to get this property? 1/4. Okay, so if I choose 1/4, my base is 1/4. So log base 1/4 of 1/4 is equal to 1. Okay. All right, this property, this last one is not as it's not as well. I would say that it's probably not as we don't need this as much as these other ones, but it's also just good to have this property, just to have it lined up on the graph. So what can I choose for what's inside the parentheses to get this property to work? 4, right? The reciprocal of the base. So if I choose 4, then log base 1/4 of 4 is going to equal to -1, right? So it's not as essential as these other points, meaning that it's not going to be as helpful. I think the most helpful is the vertical asymptote and the 2-order pairs. That's going to give you a pretty good estimation of what that graph looks like. Okay, so we should have an easy time now graphing these points and creating our graph. Okay, 1, 0. All right, let's find domain, range, intercept, asymptote. Okay, what's the domain? Yep, 0 to infinity. Yep. Doesn't get past the y-axis on the left, so it's going to be to the right of the y-axis. Okay, range. Yeah, range is always the same, right? It's never gonna change. Vertical asymptote. X equals 0. X-intercept. Yeah, 1, 0. So if it doesn't show up, then we would set this function equal to 0 and convert it to exponential form and solve for x. End behavior. So end behavior. So as x approaches infinity, f of x approaches, and then as x approaches the asymptote. So as x approaches infinity, that just means follow the right arrow. And where's the right arrow headed in terms of the y value? Is it going down or going up? Going down, right? So it's going down all the way to infinity. Yeah. Okay, as we follow the arrow towards 0, that means towards the asymptote. Where's the arrow headed? Or where's the y value headed? Positive infinity. Okay, use the graph of f of x to describe the transformations. Let's start off with log base 10 of x. Okay, let's graph this and then we'll talk about, well, actually, transformations, let me see. Actually, before we graph these two functions, let me just review a little bit with transformations. We've seen this all before, but before we list out the transformations between the parent graph and the new graph, here are the list of transformations that we can name. So the first is, let's say we have log of x. Okay, so if log of x is the parent function, then these are the things that we can add and change to log function to that parent graph, and then be able to list out these transform characteristics. So the first is the negative sign. So if there's a negative outside the expression, then you know that there's a reflection of the parent graph, a reflection over the x-axis. So we have to just understand that the negative may be attached to a number. It could be like -3 or -1/3 or -4, but we have to understand that the negative and the number seen next to it are not the same thing. Okay? They have different transformation properties, so we really need to be able to separate the negative from the number that we see. So the negative alone is going to be the reflection, and then the number alone, that means we ignore the negative and we just look at that number, and we look at that number to see, is it a number that is greater than 1 or is it less than 1? If it's greater than 1, like 4/3 or 5 or 2 or 3, then it's going to be a vertical stretch by a factor of that number. If it's less than 1, like 2/3 or 1/3 or 4/5, then it's going to be a vertical compression. Okay. Any number that is inside the parentheses, either added or subtracted, is going to shift your parent graph left or right. But we just have to understand that there's kind of this opposite from what you would expect. So if you see a plus, that means the graph is going to shift to the left. If you see a negative, that means the graph is going to shift to the right. Okay, that's what's inside the parentheses. Now, if you see a number outside the parentheses, then that's going to take the graph, the parent graph, and it's going to shift it either up or down. But this one makes more, this one is not backwards. So if you see positive, it's going to move it up. If you see -2, then it's going to move it down 2 units. All right, so let's go to the parent graph here. Y equals log of x. This is base 10. Okay. Let's list out, we're going to graph both these functions. And let's list out order pairs that we can plot. All right. Parentheses around the x. Where's our vertical asymptote? 0. X equals 0. All right, what can I do to take advantage of the second property? Choose what x value? 1, yeah. What can I choose to take advantage of this third property? 10. So log base 10 of 10 is equal to 1. And this one, not as important, but it's easy to find. What can I choose for x that will give me the reciprocal? 1/10. If I choose 1/10, I get y value of -1. Okay, so let's plot those points. Okay, second function here, g of x, this is a transformed graph from this parent graph. There's two transformations here. Can you list those out? What's changed between the g of x and f of x? Okay, good. That negative is reflection over the x-axis. What else? Shifted right. All right. List out properties here. How can I find vertical asymptote? Where's the vertical asymptote? Good. All right. Second property here, I want to choose an x value that will cause my parentheses to be equal to 1, so that I get this nice clean property for me to find order pair. What can I choose for x? 3. All right, so if I choose 3, 3 minus 2 is 1. Log of 1 is 0. The negative is not going to make an impact. Negative 0 is still 0. Okay. Log base b of b, what can I choose for x that will make the parentheses match as the same base as this base 10? 12. Okay, let's try that. Where did the 3 come from? So I want to pick an x value that will make my parentheses equal to 1, because I know that log of 1 is 0. So what can I choose for x? There we go. Yeah, 3 minus 2 is 1. And then I want to pick an x value that will cause my parentheses to be the same value as base 10. So I purposely choose 12, right? Because 12 minus 2 is 10, and log base 10 of 10 is 1, but then there's a negative, so therefore negative 1. Okay. Now there's a shift in the graph, so it's not worth the trouble to try to figure this one out. I mean, we can say x minus 2 equals to 1/10 and find this decimal value, but it's really not going to help us with the graph. So we'll leave that alone. I think this is enough to get a pretty good picture of the graph. Okay, so vertical asymptote at 2. Three, 0, and 12, negative 1. So the graph is going to be going down like this. Okay, let's get some more practice with graphing so that we feel really comfortable with it, and then we can we'll knock out one of the pages on the test review. All right, page 25. Okay, does anybody still need this? All right, page 25. Okay, y equals natural log of x, which is same thing as what? Log base e. All right. Where's our vertical asymptote? 0. What can I choose for my x value? 1. What can I choose to get the bases to match? E. Now E is a little bit less than 3, it's about 2.7, and log base E of E is equal to And this one should be pretty easy for us to find. Let's go ahead and do that. What can I choose that will allow for reciprocal of the base? 1 over e. Now e is around 3, so 1/3 I think is it's a pretty good estimation. And if I do log base e of 1 over e, I get -1. Okay. All right, let's plot those points. Okay, before we get into g of x, let's list out the transformations. There are 2 here as well. What transformations do you see what changes do you see from f of x? Yeah, vertical stretch by a factor of 3 and shift up 1. Yeah, so it's not inside the parentheses. If it's inside the parentheses, then that number is going to shift left or right. But here, the number is outside, is shifting up or down. In this case, is shifting up. Say it again. Oh, so yeah, I'm just applying it. I'm comparing f and g and see what are the changes, and then the 3 and the 1. So I have to list out what's happening based off of their locations. So the number in front, if it's being multiplied, it's going to be a stretch or compress, and the number outside, if it's added or subtracted, it's going to be either shift up or shift down. Okay, vertical asymptote. Yeah, if I set the parentheses equal to 0, there's no need to solve for anything, it's already there.
So why would y equal 1?
Oh, why would the y not equal 1?
Yeah.
Because 0 doesn't actually live on the graph. 0 is actually where the vertical asymptote is. So it's not part of the graph. Now, once we can get a value that will give us something that does exist, then we can add it to the 1.
So no matter what's outside, that's 0 will always equal.
Not 0, but whatever's not necessarily 0, but basically whatever's inside the parentheses.
Okay.
Yeah, so whatever you set inside the parentheses equal to 0, that's where the vertical asymptote is. So we don't include the rest of the problem because it's where the graph doesn't exist.
Okay.
The boundary of the dotted line. Okay, so that's where the dotted line is. Okay, next up, what can I do to take advantage of the second property here? X equals what? 1. Okay, so we got to do a little bit of a calculation here, because if I insert 1 is going to impact this portion, this log base e of x. Okay, so what's log base e of 1? 0. Okay, and then 0 times 3 is plus 1 is 1. Okay. Okay. All right. What can I choose for an x value that will take advantage of this third property here? E. So if I insert e in for x, log base e of e is equal to 1. 1 times 3 is plus 1. There we go. Okay, plot those points.
Oh, I don't know that.
All right, let's see if we can do number 4 and 5 on our own to see if these if finding these order pairs makes sense. Okay. And for 5, let me change 5 because I won't give you one where we got to, yeah, because this is hard for the property that we're going to use. So let's do this one instead for number 5. Natural log of. Mm-hmm. There'll be 2 graphing on the test. Say it again? I think both of them will have transformations on them. So there'll be like one that's probably log base E, and the other one will be like log base one of the either 2, 3, or 10, one of those numbers. Okay. Let's see.
How did you do one of the-
Oh, right here. So I chose 1 over E to take advantage of this property here. If I take the reciprocal, 1 over E will force this to be a -1. And -1 plus 3, right, add 3, right?
How did you take 3 out of the parentheses? You changed it.
Oh, sorry, I changed the problem because this one I won't put on the test because finding a value for X that will cause the base to be the same is messy. So I won't give you a natural log where there's a transformation left or right. And then to find the x-intercept, I just have to set y equal to 0 and solve for x.
All of these things say this.
Yeah,
Huh? Mystery?
we're going to get through page 26.
Sister Yang, I'm gonna leave the graphing. It's like slowing me down. So I'm just gonna go back and graph.
That's fine. All right. Page 26.
Oh.
We have 1 over e cubed. Okay, page 26. Does anybody still need this page?
Monday, sorry.
Okay, number 1. It says write each log in exponential form. So to get into exponential form, we start with the base. 49 raised to what power?
7. 1/2.
Yeah, equals.
Equals 7.
Yep, that's it.
That's it?
Yeah.
That's
We're-
all.
This, all we're doing is we're just converting from one form to the next.
That's so easy.
Okay.
Wait, I'm not using it.
Number 2, what's the hidden base? Okay, 10 raised to the,
4.5 equals X. Why don't we solve that?
this it's just a value in the calculator. We can, but we can also leave it in that form as well. Okay. As long as we get x by itself, we have our answer. Now we're trying to get from exponential to log form. So now we want logs in our expression. So we'll start number 3 here. Log base what?
3.
Log base 3. Log base 3 of
1 over 81.
81, yeah. Equals -4. Okay, number 4. Log base e of,
Natural log.
yes, you can. Log base e of,
Should just write log base C.
You could write that.
No, it's not.
equals. So you can either leave your form like this, or you can write it in shorthand form, natural log. Either is fine, but I just want to make sure that we know how to go back and forth between the forms so we can recognize that natural log is just a shorthand form of writing log base e. Okay, are we okay? 1 through 4?
Yes.
Okay. So evaluating, what we're going to do is we're going to make that equals x, and then we'll just convert it to exponential form, and then we can have an easier time solving for x. Okay, so exponential form, what's the base?
5.
Raised to the
X.
equals cube root of 25, yeah.
Wait, how do you say that? Cube root?
Cube root, yeah, cube root of 25.
Why wouldn't you just say 3 root? But if you say square root.
Yeah, I think that typically we say cube root.
So, yeah, why can't you say?
Maybe you could. It's just, we say square root, cube root, 4th root, 5th root. That's just
So we
the
can't say third root.
3rd root. That's fine. You can say that. Okay,
She just said root.
so here we would like to get the bases to match. We'll have a lot easier time solving for x if we just get the bases to match. So 25 we can represent as what? 5 squared. Yeah. So what's another way of representing cube root of 5 squared? 5 to the close 2/3, yeah. So the way we do this is whatever's in the to the right of in the exponent to the right, it's going to be in the numerator of your rational exponent, and whatever is in the root position is going to be in the denominator. So now that you get the bases to match, we can just focus our attention on the exponent. So x equals what?
X equals 2/3.
That's it.
I'm so smart. Go me.
Okay, same idea. Number 6. So if we can get that 1/16 to be a base of 2, how can I represent 1/16? 2 to the -4, yeah. And now solve for x. -4. Okay, number 7, we may not even have to do any work here. Any idea, just by looking at this, what this could be? No solution. Why? Yeah, we can't have log of a negative value, right? We can't have a 0 or negative in our parentheses. Otherwise, the graph's not going to exist at those points. So no solution. Okay, let me write number 8 a little bit more clearly here. I know there's a hidden base. I can also represent 0.01 as 1/100.
Can we have like a no calculator section on this or something?
We will represent, I think you'll be able to show all your work without a calculator. And you don't have to simplify any of the ugly values.
Don't give them ideas.
So no calculator.
Yeah, okay.
No calculator.
On the entire.
Right.
Oh, wow.
I feel like I remember you saying.
Yeah.
I feel like I remember that.
Well, some of the problems may not. Yeah.
I'm like, we can have it, but like, we don't really need it. So it's like, thanks for the use.
Let me confirm. Okay, so how can I represent 1/100?
Well, I know the answer to that one is, it's x equals -2.
We really want to spell it.
10 to the negative, 10 negative squared,
2. Yeah.
and then x equals to 7. I didn't know how to do this one because there's an E. It's stupid. Sorry.
So let's see. Properties here. Okay. So before we get to number 9, I want to talk about this property here. If I have log base b of b to the x, if I can get the base of the log and the value to match, I can basically make that go away. And then the only thing that I need to worry about is the exponent. Just the exponent is the only thing that remains.
Do you raise it to the E?
So, okay, so before I get to that, the other property is if I have a base raised to the log base b of the same base, all that can go away, and the only thing is the argument that's left over. So, natural log of e to the 4th. What's another way of saying natural log? I have log base e of e to the 4th. What's log base e of e going to do? Yeah, it goes away. The only thing left is 4. Okay, so for number 10, what's a base that I can get both sides to share? 3. Okay, so 9 is 3 to the 2. And then 4th root of 3, I can rewrite as what? 3 to the 1/4. And then now I get the bases to match. I can remove the base and just focus on my exponents.
I found out that's not 4.
Okay, to solve for x, I divide by 2. Divided by 2 is same thing as multiplying by.
So it's 1/8. Right?
Mhm.
So that's what I put. Yay. I didn't even use my calculator for that one. Just my brain.
Okay, let me talk about number 11 here. If you're looking at this saying, how can I get 2 expressions with the different bases to combine? We have to look at each individual term and see, is there a relationship between 3 and 27? 3, right? So I can represent 27 as what? 3 cubed. Okay, let's come back to this. How can I represent a way for the base and the value to match. Log base 5 of 5 squared. So 27 I replaced with 3 cubed, and 25 I replaced with 5 squared. Now we're going to take a step back and look at this from a different perspective. What do you know about log base 3 of 3? So the only thing left over is
Nothing. 3.
the 3, yeah,
3.
the exponent.
Wait, how is it? Oh,
And what do you know about log base 5 of 5?
it's also
The only thing left is,
4.
right, 2 times 2, which is 4. Oh, sorry, 2 times
Do you
2.
multiply or do you just because
We multiply. So that 2 drops down, and then it gets multiplied with the coefficient in front.
you don't keep it as a square?
Right, we don't keep it as a square.
It's just ask.
Okay, number 12 is a little messier here, but we're again going to do the same process. We're going to find a way for that 32 and 2 to match. That's right, 32 is 2 to the 5th.
The 5th.
Yeah.
Are we expected to know that? Because I did not know that.
Yeah, so we're gonna still getting the sheet calculator.
Yeah, I'll either give you a sheet or a calculator. Let me get back to you tomorrow. I'll have an answer for you tomorrow. Okay, how can I represent this with the square root?
X equals 40. What? Oh, what?
Close, but yeah, the root becomes 1/2. Yep, 5 over 2.
Oh, I did it wrong.
Right, there's a hidden base or hidden root, that's 2, so it's 5/2. What do you know about log base 2 of 2?
It's 1.
1. And then 8 times 5/2 gives us
So 20.
20. Yeah. We can, it's just, that 8 is a little messier. It's just easier to work with the 2 and 32 to get those two cleaned up. Okay, 13. We're using these properties to, log properties to expand.
How do you get 20 from 8 times 5/2?
Oh, 8 divided by 2 is 4. And then 4 times 5 is 20. Or we can say 8 times 5 is 40, and 40 divided by 2 is 20. All right, so when we're looking to expand, we're going to be using product, quotient property, or power property. So we want to separate the 3 from the x to the 4th from the y. So anything in the numerator is going to be added together. Anything in the denominator is going to get subtracted. And there's one more thing that we can do after this. Exponent 4 can come down in front. Okay, good. Okay, 14.
Can't we simplify log to 9 times 3? Right? Can't we make that log 9 times 9 to the thing?
9 to the 1/2. We could, but this is good enough. So for 14, we can get that 5th root to show as parentheses to the 1/5. And from here, you have 2 options here. You can bring down the 1/5 and then distribute everything through, or you can multiply that 1/5 through the parentheses and then separate. So I brought the 1/5 down first. And then the x squared, the y cubed, and z to the 4th can all be separated with the sum of logs. And then once I do that, the square, the cube, and the 4th can all come down in front.
Oh, where did that come from? I'm so confused.
Okay, let me show this middle step here. So the x squared, the y cubed, and z to the fourth would become log base 3 of x squared plus log base 3 of y to the third plus log base 3 of z to the fourth.
Oh, okay.
And then the squared can come down, 3 can come down, 4 can come down, and the 1/5 also distributes through. And so we get 2/5, 3/5, and 4/5. Okay, last one here. So 15, similar to 14, we can have this as natural log all to the 1/5. Bring the 1/5 down. Go through product property to separate the x cubed from the x plus 1. And then you can bring the 3 down as well as distribute the 1/5 through. Okay, let me come around and check pages 24 through 26. And then we'll finish the rest of the review worksheet tomorrow.
Can I go get my ceramics? Hey, I can. I will go back and give it back. Okay, come on.
Yep.